Hi everyone, today let's solve a Leetcode question called binary tree level of the traversal 2. So this question basically very similar to the previous question called binary tree level of the traversal, but the only difference is that in this question we're finding the bottom-up level approach instead of the top-down approach as we did in previous questions. Okay, now let's check the following example here. You see in the following example, we're starting at the bottom node from left to right, we get 15, we get a 7. Now we see the previous levels, left node we get 9. And the right node will get 20. Finally, we reach the root level, we get 3. So the result will be the 15, 7 for the first level, 9, 20 for the second level, and 3 for the root level if going from bottom to up. Okay, so you see the intuition is very straightforward. Now let's think how to solve this kind of problem. But I explained the previous question for this kind of problem. We prefer the breadth search because we are traversing level by level instead of traversing one level all the way to the end and go back. Therefore, we need a variable called level to record the level of information. And level will always starting at the root. So level will initialize at 0. And after that, in this question, let's say we need a result array. The result array is initially empty, but since here we are going all the way from bottom to up, right? So the root level should be the subarray at the end of the result. So let's use a different color for the root array. We have 3 here, so append a subarray at the end of the result array, and we include this in node 3. And after that, we want to reach the next level. So let's use different color. You see next level we have 9 and 20, so we append a subarray for next level, and we want to add these 2 nodes inside next level. And finally, for the last level, let's use different color. We have 15 and 7. We append a subarray and beginning of the array, and we add these 2 nodes. Okay, you see, now the result finished, and we can return. Now, finish the explanation. Let's dive into the coding part. Well, the first thing is to write down the main function, right? So let me copy it down. And for the main function, we have to initialize level as 0, indicating it's root level. We need to result array. Let's call the helper function. We'll pass in the root, the level, and the result. And finally, let's return the result main function to finish. After finishing the main function, the next step is called the helper function, right? The helper function will have self, the root, the level, and the result. Okay. So if there are no roots, we want to return none, as we did in previous tree question. And after that, we want to insert instead of append subarray for each level, right? And after that, we want to insert the nodes for each subtree. And finally, we check the left subtree and right subtree should be done. Now, which coding comments for the helper function, let's write code itself. So it says no root, we want to return none. And after this, we want to insert subarray for each level. So while the length of result array is smaller than a level, we want to insert, right? Result or insert at the beginning an empty subarray. And after that, we want to insert a node for this one. So we will use this one and want to append the node value. So why do we use this? Because let me use the join here. So you see in the previous question, we are starting all the way from beginning to the end. Okay, so we are inserting first this one and then this one, this one. In the previous question, we need to use the result level, right? But you see in this question, let's use different color. Okay. So you see in this question, we're inserting the arrays all the way from the end to the beginning. If we still use this kind of approach, we will insert all numbers in this last subarray, and this is what we don't want. Therefore, we choose this approach called result minus level plus 1. So in that case, we'll first insert element in the last one, and then check the previous one and previous one, and so on. Okay, I hope it makes sense. Now let's check the a left subtree and right subtree. So you see the left subtree, we call do the left and we add level by 1 and we pass in result. And for the right subtree, we just copy paste here and make slight change. Now let's submit the result. It works. Oops, the internet I think is not very good. Okay, you see the solution path and the runtime memory usage, and overall I think it's very easy to understand. If you like this video, please subscribe to our channel and see you next time. Thank you.